Welcome to Real Civil YouTube channel. This is the third part of the series Analysis and Design of G+4 Storied RCC Building using SAP 2000. The first two parts are available in the description box where we have modeled the building, and in the second part we have done the load assignment, basically static. So in this video I am going to discuss you about the response spectrum and equivalent static analysis. So before that we have to uh, go to mass source, then we will modify the mass source, and we will provide the specified load patterns. So here we'll go with dead load. Here in the live floor, as it is less than or equal to 3, we will consider 25%. Similarly, live roof, then remaining will be 1. Brick exterior, brick interior, brick parapet, floor finish, and a roof treatment. Click on OK. Click on OK again. Okay, so let's define the function first. Go to define response spectrum. Now here you have to select the code from your country. So I am going with IS 1893 2016, and I am going to add new function. Okay, now I will give some name to the function, say IS 1893. Now I need to enter some parameters. For that, we'll go to our PDF. Last time I have explained about this. Okay, so here you can see seismic zone 4, medium soil, importance factor is 1, and the frame is special moment resisting frame. So this data will require to put here. So seismic zone is 4, importance factor is 1, soil type is 2, and as it is a SMRF, so we will take the response reduction factor as a 5. And damping ratio, we'll keep it as it is. Now click on OK. Click on OK. Now we have defined the function. Now go to define. We need to define the load cases. Okay, so first case will be response spectrum X. Okay, and here the case will be response spectrum. Now modal combination and directional combination. So here we will go with the SRSS method. Okay, I have made one special video on this also, when to go for SRSS and when to go for CQC, or when to go for absolute. You can check that video in the description box, or you can click on the I button. Okay, when the modes are well separated, you can go with actually SRSS method. Okay, so remaining data we will keep it as it is. Now here load type will be acceleration, load name will be U1, code will be, function will be, just we have defined IS 1893, and here the scale factor will be 9.81, because in spectrum all the values are given in terms of G, that's why 9.81. So click on OK. Now make copy of this case, and we will do only one change here. Instead of X there will be Y, and here instead of U1 it will be U2. Remaining things, just a minute. Yes, U2, let me check, it is U2. Yes, RSPY and U2. Okay, now when we do the response spectrum analysis, we also need to perform the equivalent static method also. Okay, so for that, go to define, go to load patterns, and here we will define the load pattern earthquake in X direction. Load type will be earthquake. Here the option is quake, and Here you have to select the code IS 1893 2016 and you have to add this. Similarly, you have to add for the Y direction. Now we will modify this load pattern because we need to put our data. Sorry, here you have to click on modify lateral load. Okay. For EQX, we will keep it global X direction. Now here our zone was zone 4, that is 0.24. Then soil type was medium, importance factor 1, response reduction factor is 5. Now here very important point is time period. So here it is better to go with user defined time period. Okay. So in our IS 1893 2016, there is a formula for this type of building. The formula is 0.09 h divided by root d. 0.09 h divided by root d, where h is the height of the building in meter and d is the base dimension of the building at the plinth level along the considered direction of earthquake shaking in meter. Okay, so height of the building is 13.2 meter and the d for x direction d is 15 meter and for y direction d is 8 meter. So if you put this value in this formula, you will get the time period in x direction 0.32 and time period in y direction as 0.43. Okay, so for x direction we'll put 0.32. Now click on OK. Now for y direction, go to modify lateral load pattern, put same data. Now for y direction, here make global y direction and 0.43, 0.43. Click on OK. Click on OK again. Now we'll analyze and we will run the following cases. RSP X will run this case. Sorry. RSP Y, EQX, EQY, and we also run the model case also. Run now. Now let's see the results and we need to do the correction if required. So go to display, show tables. Here we'll want to see the structure output in that base reaction. Click on OK. Now before that we will select the load cases. Instead of modal, remaining cases we will select EQX, EQY. Now here you can see response spectrum X, the base shear is 331.971. Response spectrum Y direction, it is 289. EQX, it is 535.888. EQY, it is 535.888. Okay. Now there is one clause in IS 1893 2016. That clause is, here you can see, dynamic analysis may be performed by either time history method or response spectrum method. When either of the method is used, the design base shear VB estimated shall not be less than design base shear VB calculated using fundamental period. Means in no case the base shear calculated from response spectrum shall be less than base shear calculated using fundamental period. Otherwise, you have to use multiplication factor VB bar dash upon VB. That means here X direction base shear is 535.888. So we'll open the calculator. Sorry. So 535.888 divided by response spectrum in X direction, base shear in X direction 331.971. So this factor we have to use for X direction. The factor is 1.614. Okay. For Y direction we will calculate. For Y direction 5, again it is base shear is same 535.888 divided by 289, that is base shear in Y direction earthquake 289.973. 289.973. So it is 1.85, we can say approximately. So close this, go to define load cases, response spectrum in X direction, modify this load case. Here you have to multiply this X direction by 1.614. Okay. So this is the modification. Click on OK. Similarly, for response spectrum in Y direction, the scale factor will be modified by 1.85. Now click on OK. Click on OK. And we will once again do the run analysis. Now again go to display, show tables, click on OK. Now here you can see 535.80 is the response spectrum, base shear due to response spectrum in X direction, and this is earthquake in base shear due to equivalent static 535.8. Similarly, 536.45 base shear due to response spectrum analysis, and due to equivalent it is 535.88. So this is how you have to modify the responses. Similarly, all the responses will get multiplied. Okay. So I hope the concept is clear. Response spectrum analysis and equivalent static analysis. In upcoming videos, we are going to perform the pushover analysis, the pushover curve, demand capacity curve, and all those things will be cleared. Okay. Thank you so much. Please like, share, subscribe the channel. Thank you. Thank you so much.